Imagine your home is on the absolute front line of a global crisis, not in some distant future, but right now, today. Well, for the island nation of Vanuatu, this isn't just imagination, it's their daily reality. We're going to take a look at how science and data are becoming literally the most powerful tools for survival in one of the most climate-vulnerable places on the entire planet.
What you're looking at here, this isn't a maybe or a what if. This is the immediate aftermath of extreme weather. Daily life just completely upended. It's a pretty brutal reminder that for the people of Vanuatu, the climate crisis isn't coming. It's already here.
I mean, that is a huge question, right? When rising seas and supercharged storms are threatening your home, your food, your entire future, where do you even start? Well, as we're about to find out, the answer isn't about building bigger walls, but about building smarter plans. And those plans are all powered by information.
So, to really understand the solution, we first have to wrap our heads around the sheer scale of the challenge they're facing. This isn't just about a bit of bad weather. We're talking about a constant, compounding threat to the very existence of these communities.
Just look at this. When an international airport floods, it's not just a travel headache. Think about what that means. It cuts off vital supplies, it cuts off tourism, it cuts off connection to the rest of the world. This is what vulnerability looks like on a national scale. Your most critical infrastructure literally underwater. And that's not just a feeling, it's a globally recognized fact. The World Risk Report consistently puts Vanuatu right at the top of the list for its vulnerability to natural disasters and the impacts of climate change. The risk here is real, it's quantified, and it is absolutely extreme.
And it's not just one thing. It's like they're getting hit from all sides. The cyclones are getting stronger. The sea is rising faster. The droughts are lasting longer. And then, when it finally does rain, it's often a total deluge that causes massive flooding. It's just this relentless, vicious cycle of extremes.
And this number, wow, 48%. Just let that sink in. Nearly half of all the buildings, the roads, the homes, they're all within a stone's throw of the coast. Now you combine that with rising sea levels and super intense storm surges, and you have a perfect recipe for disaster.
But here's the thing. This is not just a story about an overwhelming threat. It's also an incredible story of empowerment and innovation. Because when faced with these facts, Vanuatu and its partners came up with a whole new strategy, a new weapon in this fight. And that weapon is information. It's delivered through something called Climate Information Services, or CIS for short. Now, this isn't just about collecting a bunch of data. The whole point is to translate complex climate science into practical, usable advice that helps everybody from a government minister to a local farmer make better, safer decisions. This quote from the project's funding proposal really gets to the heart of the ambition here. It talks about a paradigm shift. That means moving away from just reacting to disasters after they happen, and instead proactively building a resilient future using the best science we've got.
And the project that's making this all happen is called Van-KIRAP. The name itself says it all, right? Vanuatu Climate Information for Resilient Development. This is the banner under which all this incredible work is happening, turning that big idea of climate information services into a reality on the ground.
Okay, so how does this actually work in practice? I mean, how do you take this massive, global-scale climate data and make it useful for someone who's just trying to plan what to plant in their small village garden?
Well, it happens in a few key steps. First, scientists gather data from all over the world. They feed it into these super powerful computer models to project what the climate will look like in the future. And then, and this is the really critical part, they downscale it to make it super local, before finally turning it all into user-friendly, actionable tools.
Here's the core problem they had to solve. A global climate model might have a single data point that covers 150 kilometers. But for a country made up of over 80 small islands, that's kind of like trying to read a street sign from a mile away. It's just way too blurry, too low resolution to be of any real use for local planning.
This is where downscaling comes in, and it's brilliant. It's basically a set of techniques that uses local information, like the shape of the land and other conditions, to add high-resolution detail to those blurry global models. It brings the whole picture into sharp focus, so you can see the climate patterns not just for the whole Pacific Ocean, but for one specific island, one specific coastline, or even a single valley.
So this all leads to the most important question of all. How does this incredible science actually help people? How does a downscaled climate model translate into a safer village or a more productive farm? Let's take a look.
Let's start with agriculture, because for 60% of the population, farming is how they make a living. It's their household income. So when the climate starts changing, their entire way of life is put at risk.
So if you're a farmer, you're asking yourself a really tough question. Kava is a hugely important cash crop there, but it's very sensitive to things like temperature and rainfall. So how do you know if the land you've always farmed on will still be any good in 10, 20, or even 30 years?
And here's the answer. Van-KIRAP used that super detailed downscale data to create these things called climate suitability maps. These maps literally show farmers which areas are going to get too hot or too dry for kava, and which new areas, maybe at higher altitudes, might become perfect for it. It's basically a roadmap for the future of their farms.
And what's so cool is how diverse the applications are. It's not just for farming. So for farmers, there's an AI-powered platform that gives them tailored weather forecasts. But then for the tourism industry, which is also vital, there are coastal inundation maps that show exactly which areas are at high risk from sea level rise, helping them plan and build safer hotels and resorts.
And just look at this incredible map. This shows the predicted wave height during a massive 1 in 50-year storm. Those bright colors show where the most powerful, destructive waves are expected to hit. Now, this isn't just some academic exercise. This is literally life-saving information for planning coastal defenses and protecting entire communities.
Now, a project this huge, this ambitious, this important, you absolutely can't do it alone. It takes a whole global network of partners, all working together to turn this data into real action.
The project is being led by the people who know the region best. You've got SBRET, which is the big regional environmental agency managing things from that level, and then Vanuatu's own Meteorology and Geohazards Department, the VMGD, is running it on the ground nationally.
Then you have the scientific heavy hitters. All that complex climate modeling and downscaling work comes from world-class partners like Australia's science agency, the CSIRO. And the whole thing is funded by the Green Climate Fund, which is an international body set up specifically to help countries like Vanuatu build resilience to climate change.
Which brings us to our final question. The VanKIRAP project is just an incredible model of how you can turn global science into local action. It shows that, yeah, you can't stop a cyclone with a computer, but you sure can use data to save lives and livelihoods. So is this what the future of climate adaptation looks like? A blend of local knowledge, national leadership, and international science, all working together to give people the tools they need to not just survive, but to actually thrive.